Yes, no problem.
Okay, let's start. So we already in next flow. We will continue learn next flow together. So thank you for Fadin and team to prepare the slide. Actually, next flow is opening tutorial every year. They publish at the training.nextflow.io. And every year, we should be able to take the material, make it as a slide, and then reproduce or re-deliver the training for Data Science Center in University of Indonesia. Yeah. So Fadin already did that. So I will cover the slide. And after that, Fadin will continue with some demo of some workflow. So this is the fundamental training of Nextflow. So there is, I think, 3 parts of the training materials. We may not be able to complete within one session. So let's start by the introduction first, and then we'll continue next week, and also reproducing more and more workflow from Nextflow. So Nextflow is very active right now compared to SnakeMake, compared to Galaxy, because Nextflow have more enterprise-ready features for modern workflow. Okay, so take a look at this example of modern workflow. So let's say you have data from gene sequencing device in terms of PASQ or BAM. And workflow is collection of the independent process connected in kind of like a network, yeah, or some people see it as a graph, or some people see it as a flow workflow, but it's actually collection of some process. Input of the initial process goes to the next process, etc. So if you see here, there is 2 input files, FASTQ and BAM, performing many tasks, yeah, many independent tasks. There is eukaryotic nuclear genome, microbial or organelle genome, metagenomic profiling and reference, this kind of process that follow in that workflow. Okay, so usually our mindset for the workflow is not to build from scratch, but improve what is existing workflow in Nextflow that is already produced by expert or by bioinformatician that are performing the workflow together. So data analysis workflow, usually from large data set, because genomic have a large data set and very heavy data. So we need parallelization. So we need to perform it in parallel way. Like, for example, we can spawn for 100 seconds for 100K jobs over cluster. Okay, so we cannot do in one process. Otherwise, you need more compute power to do that. Okay, so Nextflow provide many features for performing a modern workflow. Sometimes they call it findable, accessible, interoperable, reusable, equitable, scalable, and tested. Okay, so initial fair, findable, accessible, interoperable, and reusable is the dream of all the bioinformaticians, that we should not be able, we should not put the workflow as a black box, but we need to make the workflow available for others to improve. Otherwise, we are stuck, or we cannot make innovation faster. Okay, so this is the design principle of Nextflow. And Nextflow, as I introduced last week, is very easy to use. Just download the executable, but you need to install Java before. And Nextflow is defined by Groovy. Groovy is a Python style language. If you don't know Groovy, don't worry. In Nextflow tutorial, you have the tutorial for Groovy. And also ChatGPT can help you to implement the code if you know what to ask to ChatGPT. Okay, so Nextflow script. written in Groovy, but it doesn't mean Nextflow task or Nextflow process have to be written in Groovy. You can use R, you can use Python, you can use Bash. Bash is actually a scripting language in Unix. So anything that you can define in R or in Python, Nextflow can make the workflow out of it. Okay, so Nextflow working to define the orchestration within the data flow programming. You can use many other languages together with Nextflow. So Nextflow has a runtime. So it says runtime, you can see what happened inside. You can see the log file. Last week you see that. But Nextflow is open source as well. You can download Nextflow and you can get many workflow in NF Core. Okay, this is the example of the task when you run in command line. So task example in Nextflow is, for example, BAM memory reference. Yeah, and this is the implementation. In each process, usually have input, the script itself, and the output definition. You have to define what is the input file or input process and output file or output process. And then you have to define the using the Groovy language. Okay. You can also do task composition between one task to another task, like the output of the first one becoming the input of the next one, right? Like align sample here to index sample. So the output of the align sample is a BAM file, and then it turn into be it turn as an input of the index sample process from the previous process. Okay? So you already see Hello World last week for introduction for Nextflow. I hope you already be able to run your Nextflow first workflow. And today we will have the simple RNA sequence workflow maybe from Fadin. I will stop here and give to Fadin and intern of Calbe to give more example before we continue to learn more concept from Nextflow. Please, Fadin. Okay, so there's interesting project from community called Dolphin Next. If you're interested, you can install Dolphin Next. So what is Dolphin Next? It's actually user interface for Nextflow. It's open source. I tried to install before, but it's not successful yet. But if I can run on my Docker, I will show later in the next lecture next week. Okay, so this is very interesting. Let me show you. Okay. This is Dolphin Next. So you can have user interface, and then you can take some workflow, pre-existing workflow, and change the input file and reuse the workflow using web user interface. It's actually open source. You can download the source code, and it's quite interesting if someone of you want to make as your master degree thesis. There is many other projects for making web UI for Nextflow, like BioFlow. Okay, this is just one of it that I think is worth to see. Okay, so you can add new process. You can define your process here. You can define the input of the process, output of the process. You can combine the process, implement your process using Python or other language. But using these tools, you can be more productive on performing the Nextflow. There is a code here for script process, but you can also use Python or R, yes, for the process. Okay, so very interesting ecosystem for Nextflow. And also Nextflow maintain a repository of the many pipeline. You can see here the pipeline, many of them. You have to learn from Fadin and in Kalbe intern team how to utilize catalog, pipeline catalog from the community. So you don't have to do from scratch, but you reproduce and improve existing workflow for your data. Okay, having said that, I think that's all from me today. And Fadin will continue for some demo for based on the training from the Nextflow training material. Please, Fadin.
Okay, thank you so much, Mr. Risman, for introducing to us about Nextflow. I will share my screen first. Okay, hopefully you guys can see my screen. Good afternoon, all. My name is Fadin. Today, me and my friends Selfie and Haikal will introduce to you guys about fundamentals training about simple RNA sequencing workflow. And as Mr. Risman said in training.nextflow.io, maybe I can send you the link in the chat box. In the training.nextflow.io, the Nextflow training community training portal have a lot of training materials such as fundamentals training, advanced training, and also applied training. This is new. From this month, we can launch the Hello Nextflow, NF Core pipeline, RNA sequencing variant calling, and also troubleshooting exercise. For today, we are going to learn from the fundamentals first, and this is the perfect training for beginners. So we get to know how to use fundamentals in the Nextflow. Okay, we can click on that. And as you guys can see in the left side, the fundamentals training have several parts of this tutorial. And if you click next, for the environment setup, there are two main ways to get started with Nextflow Fundamentals Workshop materials. The first is that we can install the requirements locally in your own PC or laptop, which is best if you're already familiar with Git and Docker. And besides that, the second is that we can use Gitpod environment, which is best for the first timers for the beginner scenario. And because the Gitpod contains all of the software, the Docker image, and data required for this workshop. So we can go on and click the Gitpod in this field, and it will pop up the to create a new workspace. If you haven't logged in, you can log in with your GitHub account, and we can click continue. So the Gitpod will prepare and take the GitHub repository from Nextflow training and make it Gitpod or spaces that we can utilize it online. So in this section, we are going to move on to the Gitpod. As you can see, in the left side, it contains all the repository that already in the Nextflow GitHub. Then the right side of the panel, we can see the browser, simple browser, so we can learn and code in one UI. So we don't have to go back and forth because it is already being in this one display. And you guys can click launch the fundamentals trainings. We can click next and then click next to the introduction. Okay. So for the starter, from the basic concept, as Mr. Risman already said, we are going to have a lot of experiments on the process and also the channels. So the process is that the process will take an input and the output and what the task is going to work on. So we are going to define, and it is already being defined first with the Nextflow training. So we are going to take a look on that. And we can click next and moving on to the third part, which is the simple RNA sequencing workflow. This is the real-world biomedical scenario, and we will implement a proof of concept or POC RNA sequencing workflow, which have four main tasks, which is first one is indexes a transcriptome file. The second one is performs quality controls or QC. The third is performs quantification. And the last one is create a multi-QC report. And don't worry, I will go slowly and explain it to you guys what is all in this each steps about. And don't be shy to ask a question. If you guys have question or trouble, let me hear it in the chat box. Okay. For this main process, we will going to use a 7 scripts that already in our file explorer. You can see in this left side there are script number 1 until script number 7 in the Nextflow format or .nf. And each script will build on the previous to create a complete workflow. So for example, in the script 1, it will continue to the script 2, to the script 3, to the script 4, moving on until the script number 7 that we have a complete workflow in the script number 7. So we are going to learn simple, slowly, and also step by step from the beginning, and we are going to have a complete in the script number 7. Okay. Also in these scripts, we are going to learn with using the 3 kind of third-party tools that are well known by many bioinformaticians. There are 3 kinds, and the first one is the Salmon. If we click on this link, it will redirect you to the GitHub from the Salmon. And this tools is going to help us with quantifying the expression of transcripts using RNA sequence data. And Salmon use news algorithm, and also it's performed its inference using an expressive and realistic model of RNA sequencing data. And you can use it and install it on your environment to do bioinformatics projects. And the second is FastQC. If you guys remember from our last from previous week about the Galaxy project, we use FastQC and also multi-QC. And for the FastQC, we are going to use these tools for quality analysis of high throughput sequence data. You can think of it as a way to assess the quality of your data. If we click on this, we are going to redirect to the FastQC repository. So this is from Babraham Bioinformatics, Babraham Institute. As you guys can see, the interface is the same that the graphic, the statistic that pop up in the Galaxy projects. It will show us the quality score across all bases. And for this example, it is shown the quality score across all bases in Illumina gene sequencing instruments. You guys can use it and install it in your environment for any other bioinformatics projects. And the third one is multi-QC. The multi-QC is the and like we are going to have a final report, HTML report format for easy viewing, easy interpretation, and also we get what is going on in that QC file. And it is useful for summarizing the output from numerous bioinformatician tools. If you click on this, we can see that the multi-QC is supported by Secura, and maybe next week or the next 2 weeks we are going to learn about Secura also. And Secura is the bioinformatics platform that we can learn Nextflow predefined pipeline that already in Secura like TerraBio or Galaxy. Then we can also just click the run, and it's going to run the pipeline that already available in Secura. So multi-QC, this is the example of the reports. It is pretty much the same as like in the multi-QC in the Galaxy project. So it's good that you guys already familiar back then in the Galaxy projects. And this week we are going to bring your memories back about the fast QC and also for the multi QC. Okay, hopefully you guys already opened the Gitpod Nextflow. So we can start look at the script number 1. You guys can open it, the script 1.nf. And from this, we can see that there are some 1, 2, 3, 4, 5 line. And as being said by Mr. Risman that the Nextflow is built on top of Groovy language. So it is similar to Python, but there are different kind of like syntax. Like for example, to print out, we are going to use println. And in this section, we are going to define what is the parameters that we are going to use. For example, in the number 1, the line number 1, params.read, we are going to locate which path in our file explorer that located the reads. Reads, it means that the raw gene sequencing instruments, high throughput gene sequencing file like FASTQ. And so we are going to take a look on that. It is located in this data. And here we have like 1, 2, 3, 4, 5, 6, 6. And for the example, like gut, liver, and lung, each have 2 FASTQ files. So we also can combine this FASTQ file to call out to specific to the params can read this path file. And the second one is params.transcriptome file. Also, we can specify which the transcriptome file is being located on in our file explorer. And the third one is projector multi-QC. And also for the 5, it's going to print out to our terminals about what is inside the params.read variables that we are already declared first. Okay, so for Nextflow, we can type in your terminal in here. We are going to have to take a lot of command line interface code, and this is we are going to export. You guys can simply copy paste it, or you guys can type in Nextflow run script 1.mf, and just like that. So for running any kind of script in Nextflow, you just simply type in Nextflow run, and you can click enter. And Nextflow will execute the script, and in our terminal is pop out the results is reads workspace gitpod nf training data. It is basically the inside, what is the inside of the variable params.read. So it is pretty much working on and having no error. And also we can modify directly in our terminal, in our console, anytime we can, anytime we want to execute our command. For example, in this, we can see that we can modify the reads like this. For example, if you guys can see in the left side, there are different types of file name like lung, gut, and liver. For this, I want to modify it so it can return the output is going to be the lung, not the gut. So we can specify it like Nextflow run script 1.nf dash reads, and you can copy the path below, and we can click enter. And yeah, the output, it will produce the different kind of output because we already modify the reads params, and it is going to give us the lung, not the gut file name. Okay, so it is pretty much the same. And also in this, we kind of have an exercise in the training Nextflow. We can add a fourth parameter named out there to script number 1 and give it the strings results. For example, we can copy the code line number 4 and you can paste it in here. And also we can modify the script also and add the log info. So it is going to be, every time we run the script, it is going to have the log information. For example, in this script, we are going to have a headline. It is the RNA sequencing Nextflow pipeline. We are going to get what is the transcriptome file, param threads, then and also the out there with our previously predefined in the params variable. So we can click copy and paste in. Okay, and you can rerun it. Okay, as you can see, the log info already have our pipeline and the transcriptome file, the reads, and also the out there. And in this step, the checkpoint is that we already learned how to define parameters in your workflow script. It is just use the params dot and what kind of parameters that you want to specify. And 2 is how to pass parameters by using the command line. You can simply type in dash and your parameters and what kind of differences that you want to make. And the third one is how to use log info to print information and save it into the log execution file. Okay, this is the first part. Second part, we are going to create a transcriptome index file, which is we are going to use process. And in the Nextflow allows the execution of any command or script by using a process definition. And as I mentioned before, a process is defined by providing 3 main declarations. The first one is input, the second one is output, and the third one is script. We are going to keep in mind about that. And if we click that, it's going to direct us to the Nextflow documentation if you guys want to check out that. And to add a transcriptome index processing step into our pipeline, we will going to add this following code block to our script in the script number 1, like this. We are going to put in the line number 18. And yeah, just like that. But alternatively, this code block has already been added to script number 2. So we are going to take a look on that. You guys can move on to the script number 2. And in this script number 2, there are already params that we already defined, the log from the script number 1, and also the process that we are define the process name index that creates a binary index given the transcriptome file. So the process is already being defined with the input, output, and also the script. And the last one, we are going to create a workflow. For the workflow, we are going to specify the channel. So the channel will take the process and also what is the input. Okay, so you guys have to remember the previous picture from the second part of these tutorials that have explained about what is the workflow, what is the process and channel. And with that, we can already have this one. Okay, and we can already use the Nextflow run command to execute script number 2. So we can copy paste into our terminal and you can run it. Okay, and this execution will fail. And this is okay because we don't have the Salmon. So the Salmon is the third party tools that it's not in our environment yet. It is somewhere, but not in our environment because it's third-party tools that come from outside. So we have to bring the salmon inside our environment. And how to do that is we can use Docker containers uh, in like your local, you can set up and in your PC or your computer. But for now, because we already use Gitpod, in this Gitpod, it is already have a Docker container image with the Salmon software is available and has already been defined in our nextflow.config file. So if we take a look on that, it is already defined that we have a process container in here defined and also the Docker run option. And if you guys haven't familiar about Docker, maybe you can take a look on what is Docker, and also what is the Docker container, Docker image, so you guys have a better imagination of what is going on in the Docker section. And to do this, we are going to add the command line option with Docker to launch script number 2 with the Docker container. So we can copy paste on our terminal. And we'll see whether it's or is it working or is it or not working. Okay, as you guys can see, it is working perfectly because we already put with Docker options, so it is already have the Salmon software inside of our Docker images, Docker container. And as we guys can see, we have the log information and also the process that execute perfectly. In this script number 2, we only have one process called index, and it is working perfectly 100% 1 of 1 because we only have one process. Okay, and to do the Docker enable, so we don't have to run at the with Docker every time we want to execute our command. So we can enable Docker by adding Docker enable true in our Nextflow config file. To do this, you guys can move to the Nextflow config and add this docker.enable true. And we can run the any kind of script in the script number 2 or etc. because we are already defined that we are enabling our Docker. Okay, and for the script number 2, we are still in the script number 2, guys. We want to print the output of the index channel by using the view operator. And we can add this following to the end of our word block in here. We can type in index underscore ch dot view. If you guys want to check what is going on in the view operator, you guys can click that, and we are going to redirect to the view. It will return Q channel or value channel. Okay, and we can also specify the execute requirement in each process. So for example, in this process, I'm going to locate it for like 2 CPUs to execute this process. We can edit that under the process declaration like this. We click enter and we are going to declare that we are going to use 2 core of CPUs to run the index process. Okay. And then you guys can rerun the script number 2, but like this, don't use the with Docker and it will execute perfectly. Okay, if you guys want to check out your structures files tree in our file explorer, you guys can type in tree work and it will come up with the output like this. We can see what is going on inside of our file explorers, like what kind of file that already inside of our nf-training. Okay, To summarize, in the second part, we are already learned how to define a process executing a custom command, how process inputs are declared, how process outputs are declared, how to view a channel using this dot view, how to add a directive to a process using this in after we declare the process. Okay, so we are going to move to the third file, which is collect read files by pairs. And there are numerous channel factories that can be used to create channel. And in this section, we are going to use from file pairs channel factory to create a channel of read pairs. And from file pairs will that are the channel factory will take a glob parent as input and returns a channel of tuples. And each tuple contains two items. The first is the read pair prefix, and the second is a list of path to read files. Maybe it's going to confuse you guys, but you guys can see in the output, and you guys hopefully can understand it better if we are going to work on that together. And by adding the view operator also to the read pairs channels, you can see the contents of the channel. So for example, like this, we can take a look at read pairs underscore ca dot view, and it will print up something like this, the GOT, and what is the path file for the two file FASTQ file in this data GGAL, and also it will return the each path file from each FASTQ file. Okay, so we are going to move to the script number 3. This is the code. We are going to run this. It is already use read pairs channel. We are going to copy paste and run. So we also have to put this in our 19 line, and we are going to rerun it to so it will print something like this. Yeah, it is come up perfectly. The gut, the liver, and the lung, and also the path from each type of file. And for example, like gut underscore one, gut underscore two FASTQ, and also for the liver and also for the lung. It came up with the kind of pairing channel view. And for the set operator, it is the additional information. You can also use the set operators in place of assignment to define the respect channel like this. So you guys can replace it in here if you want to try it. And also you guys can check if exists option from file pairs to check if the specific path contain file pairs like this. Check if exists true. And I leave it to you guys to experience and exercise it on your own. And for summary, in this step, we have learned about how to use from file pairs to handle read pair files because we have the pair files, and how to use the set operator and how to use check if exists. For the second and the third one, I want you guys to experience and have fun with this second and the third section. Okay, that's it for the part number 3. We are going to move on to the part number 4, and I will hop up to Selvi to introduce about the perform expression quantification. Okay, thank you so much, guys. Selvi, please continue.
Okay, thank you, Kak Fadin, for your explanation. So let me share my screen. All right, we can continue with the next section, which is perform expression quantification. So we are going to open script number 4. And you can see that it is similar to the previous scripts as it's built from the same base. And we have got our parameters defined and the location and the definition of step, which should be the same as before. And here also we have our channel factory here. And the next step is quantification. So quantification process is a bit more complicated than the index step because it has two inputs. So the index file and the read file pairs we just created. And the interesting part about the read here is the way that it is structured as a tuple. So each element in the channel is a tuple containing the sample ID and the corresponding file path, which is reads. And this is shown by the channel factory output in the section 3 before. And so if we run the script 3 again, we can run the script number 3 with this command. Can copy and paste to the terminal and enter. So we can see here in the output, we can see tuples like got, which is sample ID, and then file path here. And we can back to the script number 4. Here in the quantification process in the script, we are running the summon tool with the quant option as opposed to index in the previous step. And we specify the number of threads and the index and the library type here and the index file, which is Salmon index, and the read files, reads 0 and reads 2. And the output of the quantification process is named after the sample ID. And we back to the section 4, 3.4, and to run this script, we use the command nextflow run script number 4 and add rhythm. And by default, it will run on a single sample from the data. However, we can add more samples by providing the additional read file paths. And we can copy this into the terminal and click enter. Okay, so the output here, we see that quantification step will run for each sample. We have 3 samples. And then next, I will introduce the directives here. We can click the link here and we can see the documentation about directives. So the directives allow us to modify or decorate the processes, and we will add two directives to the quantification process. First, we add a take directive to the quantification process to provide a more readable execution log. And then the second, we will also add a publish dir directive to the quantification process to store the process results in a directory of your choice. So in here, in this script here, we copy this directive take and publish dir. We copy it to our script number 4 after quantification and before the input. Here we can copy, paste, you can paste. And then we run again this script with same command. Here we copy and paste. And click run. So after adding these directives to the quantification process, we should see the process label with the sample ID. For example, salmon on gut, and the output file published to the specified out there directory. Salmon on sample ID. Okay, so we have the output here. So we can see that for one of them, we have got this label, so which is salmon on gut now. So instead of just being quantification 1, 2, or 3, like for we add take. And for publish dir, now on the live site here, you should notice a small section displaying the result here. So as we can see, in here my result appear here, and I have results for the gut, liver, and lung. We can access. Okay, so in this step, we have learned how to connect two processes together by using the channel declaration, and how to resume the script execution and skip cache steps, and how to use the take directive to provide a more readable execution output, and how to use publish dir directive to store a process result in a path of your choice. Okay, so this for section 4, and okay, so I will finish here, and maybe we will continue in the next week, and I will return it to Kak Fadin.
Okay, thank you so much, Selvi, for introducing to us about the 4 section. So in this fundamental training for the section of simple and RNA sequential workflow, we are going to continue our lesson in the next week for the half and the until the end for the 5, 6, 7 script. We are going to continue to learn about the QC and how to log and how to execute a report in the next week. And unfortunately, we are already in our end of time. So hopefully you guys already getting more familiar about Nextflow, and hopefully you can try and learn and follow the instruction in the Nextflow tutorials training link. And we can continue our lesson in next week. And if you guys find any troubles, please feel free to reach out to us in the WhatsApp group or personal chat. Okay, maybe I want to ask for the last time, is there any question from you guys? Okay, maybe Haikal, do you want to add something for the final of our lesson today to summarize?
Yes, Kak Fadin.
Okay, go on.
Summarize of a workflow implementation using NetFlow. Key component step 1 workflow parameter and Docker integration. 2 data processing analysis into the point tasketon indexing quality control repair to handling expression to configuration and then advanced workflow feature, and then workflow management and final GitHub integration. In this conclusion, it is tutorial building and managing a bioinformatic workflow using NetFlow. Showing in holding compact data biological analysis with its providing in managing NetFlow. Enough, Kak Fadin. Back to Kak Fadin.
Okay, thank you, Haikal, for adding the information. So hopefully that will summarize for our lesson today. We are going to meet up again in next week. Thank you so much, guys, for attending this class, and see you guys next week. Thank you. Bye-bye.
Thank you.
Thank you all.